All right, test one, review solutions. All you're doing on this test is finding derivatives, but you've got to simplify your answers. Otherwise, what's the point of taking a derivative if you can't use it for something later? So you see, this is just a polynomial. Polynomials are simple. They're just power rules. So I multiply by the 2, subtract 1 from the power here. It's going to give me a 6x. Derivative of 5x is 5. Derivative of 2 is a 0. Same thing for this problem. I wrote it out for you step by step here, but at this point you should be multiplying 4 times 7 to get 28, 3 times -4 to get 12. The powers go down by 1. Make sure you've got the power rule down. Derivative of a constant is 0. The way this problem is written, you're expected to do a product rule derivative. It's easy enough to check your answer by foiling this stuff out and going piece by piece, but I would really like for you to do a product rule derivative. So derivative of the first gives me 10x minus 6. Copy the second exactly as it is. Big fat plus for product. Copy the first exactly as it is. Derivative of the second is a 2. Then this has to be FOILed out, and then you distribute the 2 and the plus here, and then you combine like terms to get your answer. Okay, number 4. You see you have a radical, but you should recognize at this point that a square root is just a 1/2 power. So the first thing I have to do is rewrite this with an exponent. Now you can distribute this and have a fractional power for 2 pieces and then do that derivative and simplify it, or you can do the product rule right here. It's written as a product, so that's really what you should do. Okay, so the derivative of this is 1/2 x to the minus 1/2 because you subtracted 1 from the power. Copy the second, plus copy the first. Derivative of the second is just 2. I have an extra bracket right there that I don't need. Sorry about that. So I'm taking this stuff and multiplying 2x. So 1/2, I rewrote that as a root. Makes it easier to see it. So the 1/2 multiplies the 2, and the 2's cancel. And I get x on top, root x on the bottom. This actually cancels. Let's look up here. This is x to the 1 minus 1/2 gives me plus 1/2, which is the square root of x. You should also see that x divided by the square root of it gives me a square root of it. All right, this guy times this guy is going to give me a negative 5/2. X to the minus 1/2 puts the root in the denominator. This is just 2 square roots of x. Combine like terms, I'm going to get 3 square roots of x and this guy right here. So this is acceptable, but you notice how this was multiplication in the first place. So I'm just going to get a common denominator here. That means I got to multiply this thing by 2 square roots of x, which gives me 6x. And everybody's over the common denominator. Either one of these is acceptable. Number 5. All right, number 5 had a mistake in the solutions. I can't believe that I let that slide past me. I shouldn't do things when I'm tired, right? So let me zoom in a little bit. On the review solutions that were posted, I left out that square. You have a quotient rule. The bottom is squared, so this will be a chain rule derivative when I get to it. So the quotient, that's the overriding rule here, is the bottom exactly like it is, times the derivative of the top minus the top, the derivative of the bottom, which is 2 blob to the 1 derivative of the blob. All over the bottom squared. Now if I have the bottom already squared and I square it again, what am I going to get? I'm going to get it to the 4th. But is it because I'm adding the 2's or multiplying? Okay, I'll tell you. It's because you multiply the powers. When you have a power to a power, you always multiply the powers. So let me get the rest of my work on the screen here. Okay, now, so I'm just going to make this pretty, right? I'm going to go through this term, put my number and my blob, go through this term. I've got a 2 times a 1, so I pull the 2 out front. Notice there's a big fat minus in the middle because it's a quotient rule. And the only thing left other than the 2 times the 1 is just the blob, so I copy the blobs. Now I've got everything in order. I want to go through each term separated by the minus and pull out common factors. Well, they both, the 2 and the 3 have nothing in common, but they both have an x minus 6, which can factor out. In this case, if I pull an x minus 6 out of this, I'm left with a 3 and another x minus 6. That's what I didn't have on the original solutions. So it's 3 times this blob, then a minus sign in the middle, the 2 stayed. I pulled out this guy, but I left this guy. So the 3x minus 4 stayed. Now I distribute the 3, distribute the minus along with the 2. Don't forget the minus sign because it makes that a plus 8. Combine like terms in there. This guy, since he's been factored out, can now cancel one of them in the bottom. So I'm left with 3 in the bottom. 3x minus 6x is negative 3x's. Negative 18 plus 8 gives me negative 10, and I'm done. Sorry for the confusion, guys. This guy's easy. It's just blob to the power. So I bring down the power, reduce the power by 1. So I have 3 blob squared times the derivative of the power. You always have to multiply by the derivative of what's inside the parentheses. Okay, number 7 is a quotient, but you have chain rules on the top and the bottom. So quotient rule says copy the bottom exactly as it is. The derivative of the top, blob to the 4th, is 4 blob to the 3rd derivative of the blob. Big fat minus in the middle because it's a quotient rule. By the way, because it's subtraction, the order matters. Always copy the bottom first before you take the derivative of the top. Then you're going to do it the other way. Copy the top, derivative of the bottom. The bottom is blob to the 5th, so I get 5 blob to the 4th. The derivative of the blob is a 2. Okay, now this is nasty. It's all over the bottom squared. Remember, you multiply your power, so this is to the 10th. Now, notice we started with blob to the 5th. In my final answer, that should be blob to the 6th. That's how I know I've done things right, okay? But we can't cancel here and here, or here and here, because we still have subtraction. We have to factor before we cancel. So what I'm going to do is look at this term right here. I'm going to put my numbers together. So 4 times 3 is 12. The only thing left in here is blob, blob. So I copy the blobs with their powers. Be very careful not to lose your powers, like I did last time. Copy the minus in the middle. This guy has a 2 times a 5, which gives me a 10. The only thing left is blobs, both of them to the 4th. Now I'm going to use my finger and compare this to this, right? Point to both things at the same time. What's common between a 12 and a 10? Just a 2. I write it down. I've got 2x minus 7 in both pieces. One is to the 5th, one is to the 4th. I factor it out to the lowest power. Then I move to the next blob. Blob cube, blob 4th. I can pull out 3 of them. Now this is a list of what was common to both pieces. Now I'm going to put my bracket and make a list of what's left after this gets factored out. So from here, I factored out a 2, leaves me with a 6. From here, I factored out 4 of these guys. I'm left with 1 of them. These are all factored out. Then I copy my big fat minus sign in the middle, factored a 2 from this, so I have a 5. Factored all 4 of these out, factored out 3 of these, I'm left with 1. So inside the brackets, when you have a problem like this, inside the brackets is simple. You're going to distribute the 6, distribute the minus with the 5, gives me these values here. Combine like terms, I get minus 3x's, minus 67. My problem, oh, by the way, I had 4 of these on the top. Once you factored it out, you can cancel it. Notice that I end up with the 6 that I needed on the bottom, and that is factored, it's simplified, and beautiful. All right, On your review, you did not have this problem. I didn't erase it or eliminate it. I just left it in there for you to see. It's another problem kind of like a previous one. You've got a quotient right there. So you're going to do the bottom times the derivative of the top, which didn't have a power, minus the top times the derivative of the bottom, which was a chain rule, all over the bottom squared. 2 to the second gives me to the fourth. Pull the 2x out front here. Pull the 2 out in front here. I can pull out a 2. I cannot pull out an x. I can pull out x minus 1 to the first power. So here's the common factors. I pulled out the 2, I was left with an x. I pulled out one of the x minus 1s, I'm left with the other one. I have a minus in the middle. Pulled out the 2, pulled out the x minus 1, I was left with the other blob. Distribute the x, I get x squared minus x. Then I've got this thing, distribute that minus sign, makes that a plus. Combine like terms, boom, I'm done. Oh, and this guy, canceled one of these guys. Gives me 3 of those on the bottom. Number 8 on your review, the first thing you have to do is rewrite it. A square root, the top is the power, the bottom's the root, right? This is to the first power, second root, there's your power. This derivative is going to be just a chain rule. Multiply by the half, subtract 1 from it, gives me minus 1/2. Derivative of the inside is 2x. Notice that I have a 1/2 times a 2, they cancel. This x goes on the top, but that square root is negative, so it's on the bottom. The power is negative, which means divide. Number 9 is a product with chain. So derivative of the first is 2 blob to the 1, derivative of the blob. Copy the second, he's cubed. Plus in the middle, copy the first. The derivative of the second is 3 blob squared. Derivative of the blob is 2x minus 3. Now this plus sign is separating my two terms. I'm going to make this pretty by putting the numbers blobs and blobs. Make this pretty. The only number I have is a 3, and then I copy my blobs. Now, this separates two terms. Write down what's common. They both have an x plus 6, and they both have this trinomial. One's cubed, one's squared. I pull it out to the smallest power. This is a list of what's common. Now I have to make a list of what's left after it's factored out. So this guy got factored. 2 of these got factored. I was left with a 2 and 1 of these. Big fat plus in the middle. The 3 stays. 1 of these is still left because I only factored out 1. Both of these are gone, and this guy is left. So inside my brackets, I have to FOIL and then distribute. And I have to distribute this. So notice that I kept the 3 outside, FOILed the parentheses, distributed the 3, combined like terms throughout, and my answer is already simplified. Okay. Number 10. E to the power, the derivative is just copy the e to the power exactly as it is, and then multiply by the derivative of the power, in this case 2x plus 5, boom. Don't make it harder than it has to be. All right, this guy is a quotient rule, so you copy the bottom. The derivative of the top is e to the u, derivative of u. So copy e to the power, multiply by the derivative of the power. Big fat minus because it's a quotient rule. Then you copy the top and take the derivative of the bottom, all over the bottom squared. This is x to the 6th because you multiply the powers. Now I'm going to reorder this. Numbers, x's, e's. Number x's, e's, okay? Same thing here. Subtraction. I've got 3x squared e. I'm just putting things in order so I can compare them, so I can figure out what the common factors are. There's nothing common about a 2 and a 3, but I can factor out an x squared, and the e's are the same. So I pull those out front. I'll be left with a 2 and an x. He's gone. A minus sign, a 3. That's gone, and that's gone. So it's just 2x minus 3. Notice that x squared on the top can cancel. two of these on the bottom. Do not cancel here or here. Can't cancel until you have factored. Once you've factored, cancel and reduce that fraction. Number 12, the derivative of an ln is very simple. It's a fraction. Copy the guy on the bottom, put the derivative of the guy on the top. That's that simple. Unless you can simplify the ln itself before you take derivatives. If you have product, you're adding the ln's. If you have division here, you're subtracting the ln's, top minus the bottom. If you have a power on the outside, that power becomes a multiplier. If you just have plain old ln of something, the derivative is simple. All right, the next one is not on your review. It's extra, all of these are extra here. So, quotient, copy the bottom, derivative of the top minus the top. Derivative of the bottom is the derivative of e to the x is e to the x plus nothing. Now, there's not much you can do to this guy. It's over the bottom squared. It just is what it is. Now, this is a product. So the derivative of the first is 2x. Copy the second. Big fat plus sign. Copy the first. But the derivative of the ln of x is 1 over x. You've got to multiply this out. X squared divided by x is just x. And notice that both of these things have a factor of x. This is not a factor. This x is inside the ln function. You never separate these guys, all right? So I can factor out an x. I'm left with the 2 and the ln, and then a plus 1 at the back. All right, this guy right here, the ln of something under the radical. Well, this is just a square root power, right? This is, let me write that down here. This is the ln of something to the 1/2 power. And you can rewrite that by bringing that power down as a multiplier. Remember that ln is an exponent, so when you have a power to a power, you multiply the powers. So I pull that down. Now when I take the derivative of the ln, this is just a coefficient. So I have a 1 on the top and a 2 on the bottom. I copy the blob in the bottom, put the derivative of the blob in the top, see if you can simplify it. You can't, so you're done. So instead of doing the square root in the denominator and then the derivative of the square root in the numerator, which would have given me a negative 1/2 power, it's just easier to simplify the ln first and then take the derivative.